Now that we've talked about the physics of the ladder problem, I propose we do an experiment to verify that the physics is correct. Instead of an actual ladder, we're going to use this board. And instead of the board leaning up against a wall like this, we're going to keep the ladder from falling down by hooking it up the end of the ladder to a string. And we're going to be measuring the tension in this string. And that tension should be exactly equal to the normal force of a wall that is supporting the end of the ladder like this, provided that the string is horizontal. So in setting up this experiment, I'm going to make sure that that string is horizontal. I'm actually kind of lining it up with the unistrut, which is on the ceiling behind the camera. And when the string lines up with the unistrut, I know that it's level. And that's important because the normal force that would support the end of the ladder here would be parallel to the ground here. The other thing that's a little different is the friction between this end of the board and the table is not high enough to keep this end of the board from slipping out. So I've actually duct taped the end of the board to the table because the friction isn't high enough. But the physics is essentially the same as the physics of an actual ladder problem. It's just we have sort of force of duct tape instead of friction, and tension force instead of a normal force. But the predicted value of the normal force on the top end of the ladder should be exactly the same as the tension in the string. So what I propose to do is orient this ladder at 3 different angles. And to make sure I got the angles correct, I'm using this little drafting template. When it's in this position, it's 30 degrees. So if I kind of put this template here and make sure that the end of the board is along the template, I know the board is making a 30-degree angle with the lab table surface. I can also make it 60, and using this other template, I can make it 45. So those are going to be our 3 angles in this experiment. We're going to need another couple pieces of information to validate our theoretical predictions. One is the length of the board, and the other is the mass of the board. And I've actually measured these things. This particular board has a mass of 1.79 kilograms. And it has a length of 1.207 meters. So the first thing I'm going to do is make sure that my sensor is zeroed. And if I look at my sensor here, my LabQuest, I don't know if the camera can see it, but it's reading 0. So the sensor is zeroed. Now I'm going to hook up my string here to the sensor and measure the tension in the string, which again would be identical to the normal force of a supporting wall. And my LabQuest is reading pretty close. It's kind of oscillating around a little bit, but it's reading pretty close to 14.50 newtons. So that's what I want you to record for 30 degrees, 14.50 newtons. And again, I've checked that the angle is 30 degrees by using my template, and I'm making sure that my string is horizontal. I've now readjusted the length of my string and the height of my sensor here so that this board will now make a 45-degree angle with the lab table surface. And again, I want to make sure that my force sensor is zeroed, which it is. And now I'm going to connect my string to the sensor. And I'm kind of verifying that that string is horizontal by comparing it with the unistrut in the background. And now I'm going to use my 45-degree template to verify that the board is making a 45-degree angle. Maybe you can see that on camera here, that the edge of the template lines up nicely with the bottom of the board. And looking at my LabQuest, it says 8.45 newtons. So I want you to write that for 45 degrees, 8.45 newtons under the actual tension force for 45 degrees. And you can compare that to your predicted force, your predicted normal force. Okay, for the last trial, I've set it up for 60 degrees above the horizontal. So starting off, making sure my LabQuest is zeroed. And now I'm going to hook up my string here. And I've actually had to add a little extension here to my pole so I could get the sensor up high enough. I'm now making sure that my string is level. I'm using the lights, the overhead lights, as my sort of level reference here. It looks like it's pretty level. And I'm going to use my 60-degree angle here on my drafting template. And that's pretty close to 60 degrees. Maybe you can kind of see that on camera here. The edge of that lines right up with 60 degrees. And now my LabQuest is reading 4.85 newtons for 60 degrees. 4.85. So I want you to record that. Notice that the tension gets less as the angle gets bigger, and that would be true for the normal force as well. The steeper the ladder, the smaller the normal force is between the edge of the ladder and the wall that you're propping it up against. So we should have enough data now to confirm that your predictions regarding the ladder problem are close to reality. And you can complete your homework. Here is all the data in case you didn't get a chance to copy it down.